And please welcome a person who I did not hesitate to ask how much is Jakub Průša connected with 3D printers. And I found that he actually was teaching and building 3D printers at the faculty without any connection to Josef Průša. So please welcome Kuba Průša with his talk and the mic in a while. So see that there are accidental inconsistencies in what you thought might be a connection. Kuba, this is yours.
Hi, can you hear me? Okay, great. Yeah, I'm not connected to the Prusha, but like his brother work in Quanti in our company as well. But then the Josef take him to his company because he was a good developer. So anyway, hi, my name is Jakub Průša. I'm the CEO at Quanti. I'm former developer, former student here at FIT, and also, as was mentioned, former teacher. Yeah, and thanks Tomáš for being here. Just one slide, who we are, what we do, before I dive into the application that I prepared today. We are Quanti. We are doing the custom software/hardware projects for our clients. We started on Czech Technical Incubator, so we was on the 13th floor. I don't know how it was on the 13th floor when we were starting the company, but the Czech Technical Incubator doesn't exist anymore. So for the rest, we're still studying. I would recommend the 13th floor rather than the incubator itself. Okay, so yeah, we are here for 15 years, a bit longer than the guys. We are 150 plus right now, more likely developers. We have only few sales guys. We hired them recently because we started to need them, but most of us are from the Czech Technical University. Okay, and before, I believe that the best way how to show or describe what we do is to start with the short video of the projects we did, which is the Bluetooth opening solution when the mobile applications can open the doors through the Bluetooth. So I will play the video and then I will describe it a bit more. Hopefully it will work.
Touch mode, where users can leave their phones in their pockets and unlock the door by touching the intercom or access control reader.
Yeah, this is it. The marketing just shortened the video of our like 2 years work to the 7 seconds, which was like a bit sad, but I guess, oh no, this is like part of their work, I believe. Okay, so again, what we were actually doing, like what was the goal? Like originally it started as a simple idea, just create a mobile application, then which connects to the intercom through the Bluetooth and open the door. Okay, we thought, okay, that's gonna be easy. And there are some like KPIs, it should be secured, yeah, obviously, makes sense, and must be the same speed of the NFC badge. In other words, it has to open at the same speed when you just take your badge and put in front of the intercom. And we were like, yeah, okay, like we will try. It shouldn't be that hard. So we start with the first version. The only fast things on the first version was the time of the development, but all of these opening times and delays was like 5 to 10 seconds, which doesn't sound that long, 5 to 10 seconds, but like we discovered that standing 5 seconds to 10 seconds in front of the door, it's something like, okay, no one believes it will ever open. So we was like, okay, like we have to start over. We have to start thinking the better solution, how to do. But like we didn't know like where to start. Like luckily, unluckily for us, was the like there is like not so much data that we like can, let's say, the measure on the mobile phone on the Bluetooth. So we started playing with RSSI, like the strength of the signal of the Bluetooth. So the idea was pretty like straightforward. We will, let's say, measure or harvest the RSSI, and we will try to do some sort of the algorithm that will, let's say, I don't know, somehow calculate how to open the door. So we start to making the data sets, and we discovered that we need like shitloads of data sets because every phone like behave differently, and also it was like very it depends, like if you have the phone in the side pocket, back pocket, or in a phone on the laptop. Also it depends on the environment, if it's like the outdoor environment on the hall or the glass hall, or if the intercom is in the elevator. So we let's say harvest lots of data, and we start to like playing like, okay, what should be our algorithm that open the door reliably and in the fast way. yeah, we have like lots of the challenges that we have to overcome. We discovered that on Android is some sort of the Doze mode, which means that the phone is like paused for a couple of seconds for receiving the notifications to save the battery, which is great, but not that great if you want to open the door in the time. On the iOS, there was like aggressive background policies. We also discovered that the chip itself can only have like 8 parallel connections, which was like, yeah, 8 is enough until we discovered 200 more devices in the office building. And yeah, Bluetooth is not secured at all. So we have to come with also the protocol for securing the Bluetooth. We also discovered my favorite page, like Android, please do not kill my app, that I didn't know that even exists. This is like literally the web page dedicated to the different phone manufacturers and the types that like praying those manufacturers like not to killing the app on the background to save the battery. So that was also like one of the pain that we have to overcome. And like overcoming this solution, like overcoming this, the only way how we could overcome is just to hard code it to the code. If you have the Huawei, we just showed a prompt, okay, we discovered that you have the Huawei and then you need to turn off the battery optimization over here because on every phone with every manufacturer is on a different place. That was like annoying word, and we basically backpropagating this web page to our mobile phone, which was the only way. Okay, so, and what was the other solution, like, how we ended up with? Like, I need to keep in time, but it took us like literally like more than 1 year to finish the solution to be, let's say, reliable and fast. And yeah, what we do, we continuously like evaluating all of the devices around us, and we are picking the 8 top like strongest devices. This is the chip limits, and we are measuring the RSSI, and we are trying to guess or calculate, or let's say the measure, or maybe the guess is the best word, like when the device will reach the intercom. So we are calculating, okay, it's coming through the intercom. So we have, let's say, recalibrating to each device. Okay, like with the device, we know that it's like coming to the intercom. So we have to start the communication. We have to start the handshake, like, I don't know, this few seconds before. So we start the communication in advance to wake up the phone from the Doze mode, and yeah, to wake up it, do auto handshake. So it ends with the touching of the intercom as it was seen on the video, and at that time everything is already calculated and handshake is done and we can open. And yeah, this is the way how we can wake the application even on the background. So that was like a tough job, and I picked like two things like that. Two lessons learned that we discovered during the time. One of them I would name like lessons learned: do not make excuses even when you could, because as I would describe, it was like very deeply digged into the Bluetooth communication. So we have the sniffers because we need to sniff the communication and try to play on a really low level. And we discovered that there is like really the bug in the Silicon Labs chip itself, which like also making a bit harder for us, but it definitely wasn't the biggest case that we were solving at the time. But you know, like, we ended up of the time, like the client was a bit nervous. So we passed the information, okay, we are struggling with our solution and also with the chip itself. And we thought, okay, it's like, it's gonna be fine. But after like a few days, we received the tickets to Finland to meeting the Silicon Labs guys and showing up the error. So yeah, we were on a trip to Finland suddenly, and we were like, okay, what are we gonna do? Because it happened quite rarely and randomly, but somehow the miracle happened, and we were able to reproduce the error just within 2 hours in their offices, which was like great. And like the guys from the Silicon Labs, oh no, like how these guys, like two random guys from Prague with the shitty Adafruit Bluetooth sniffer can discover the error in our firmware. But nevertheless, we came back to Prague as heroes. We can say proudly that we show the error, we buy some time for finishing the solutions, our solution, our algorithm, and yeah, that was like one of the lessons learned. And the second one was the test run. Isn't always kind of test run, because like, you know, you really can't test the application from the desk because you need literally to go with the phone to the door and try to open. We are combining the solution with the gyroscope and the accelerometer itself. So you really need to go. So we hired like two part-timers who was like, they know in advance that they will have to go through the building all day long with different phones. And they was like, yeah, we don't mind. But actually they start to mind like 3 days ago and they quit the job. So we have to hire new part-timers that were willing to go all day long with different phones to give it a try. Because there was like, it was like huge metrics of like, I don't know, it was like, we have like 30 different phones, 10 different settings, which is like 300 test runs. And also, sometimes it didn't happen as we intended. So like that was working in the end like for 3 months, day to day. We were tweaking the algorithm. And the last slide, the patent. We made it to the patent application. We successfully patented the solution, the algorithm with all of these, let's say, enhancements with the gyroscope, accelerometer, even the GPS fuzzing, the rotary mechanism. And how to do the patent application would be for a separate topic we can discuss after this meeting. And also, like, there's a picture of celebration, how we received the patent. And maybe I have like these 2 shitty pictures with the beer and the plane, because I asked the colleagues like to give me the pictures that we have from the projects, and unlucky we've been only to find like 2 pictures, the Finland plane and this beer without the hat. So this is only 2 pictures we have from that project and the marketing video. That's great. And also that's all. So thanks for the attention. And if you have any questions, feel free to ask like now or after it, even like to the patent or to the solution itself. Thanks.
Yeah, there are questions in... The questions in the Slido, and before Tomáš gets up his presentation, I guess there's time for one interesting one that I listed. What happens when a stranger stands next to the door at the same time as the person with the Bluetooth device? Can the stranger enter?
Like if someone is like, we were dealing with an issue, like for instance, if there is like for someone with their own office and they left the phone on the table and left the room, if you can open because the device is nearby and you can't, you literally need to, like this is the reason why we use the gyroscope and accelerometer. So you really need to go, you need to move with the phone. So for instance, if you, let's say, start to like short chat in front of the door, and then you will try to open, it won't. You just basically need to take the phone out of the pocket and shake it a bit or a walk to enable the option to open. So if you are standing inside and some stranger came in front of the building, it can open. If you are facing to the door, and in the same way some stranger want to come in and you are close enough, then the door will open. But you have to be really close to the door to be able to open, because we also limit the threshold of the RSSI that needs to be triggered, and also it's like one of the options how you want to be secured. And funny fact is also from the Silicon Labs, they also like offer us that we can use Bluetooth 5 because the Bluetooth low energy 5 can also give you the angle of the device. I was like, yeah, that's so great. We want to like put it to our solution. And they say, okay, the only downside is like the size. The antennas are size of the A3 paper. And we were like, oh, fuck, we couldn't fit to our intercoms. But so, yeah. Yeah, I forgot. Yeah, I guess I answered it.
Thank you. I guess it's answered.